spanning tree keeps on going, and we're going to talk about timers. Okay? All right. Timers are used to allow things to happen for a particular period of time. So let's say, okay, let's look at it from this perspective. The root bridge is sending out BPTUs. Okay? All right? Those BPTUs, okay, are constant reminder that the topology is there, constant reassurance, okay, that a link is up and running. So, all right, remember, every switch or every router in its domain is a separate entity. So, in order for a switch to believe a link is down, is not sending or receiving, not receiving BPTUs. Okay? All right? And once a particular timer is hit to say, okay, look, we haven't gotten BPTUs on this port for so many seconds, this link must be down. Okay? And blah, 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 blah. Okay? So, our hello timers. Okay? All right? Hellos are originated from the root bridge. Okay? All right? A non-root bridge will never send out hellos, okay? Unless it becomes a root bridge. All right? Now, hello messages are kind of like, hello, I'm still here. Hello, I'm still here. Hello, still here. Okay? Keeping a message receiving stating that everything is okay. Okay? All right? Now, once a port is out of its blocking stage, okay, your forward delay is the time it takes for the transition to forward after. Meaning, it is that period that the port is amber before it turns green. Okay? You see how all this is all of a sudden making sense? Okay? All right? If done sporadically and not in a particular order, it can get very, very, very confusing. Okay? Now, max age. Now, this is interesting because this is how long the switch keeps a copy of the best BPDU stored. I'm not going to go into details on what really best means. Okay? It is the BPDU it believes is current. Let's put it that way. Okay? All right? The switch will wait for the time of the max age before going into forwarding delay. Okay? Kind of weird, isn't it? All right? Okay? So the max age has its purpose. Now, diameter is kind of interesting because really diameter is a hop count. Okay? And the diameter, spanning tree VLAN, whatever VLAN number, and root dynamic command, okay, allows you to manipulate the timers if you want to do it in that fashion. It is recommended to do it in that fashion. However, you can change the timers specifically to whatever you want them to be. Just make sure it's for good reason. Okay? All right? Now, what we were talking about before as far as spanning tree was concerned, and what we were looking at on Packet Tracer was per VLAN spanning tree. Okay? And there is a thing called rapid spanning tree. Okay? Which is still rapid per VLAN spanning tree. Okay? Alright? Okay? This is an 802.1d standard. You can go out and do all the reading you want. Okay? And really what it is these switches connected to each other communicate a little bit more for faster convergence. Okay? All right? Okay? That comes up with two things called uplink fast and backbone fast, which we're not going to go in detail with. Okay? All right? Now, 802.1w, okay, has these parameters here, which we're not going to go through every one of them, okay? And Rapid Spanning Tree has a lot more features. Not a lot more, but you get the idea, okay? BPTU version 2 is used for Rapid Spanning Tree, okay? And this allows Rapid Spanning Tree to recognize that it is connected to an 802.1D switch, okay? Meaning that if you have two switches that are on version 2, okay, you'll have a little extra communication, all right? BPTUs will send out all ports during the hello intervals, regardless if it's a root or not. This allows every switch to do its part with Spanning Tree. Golden. This is one of the reasons why Rapid Spanning Tree sets itself apart. Okay? BPTUs are expected from its neighbors. If 3 BTUs are missed in a row, the neighbor is presumed down. Okay? Alright? Now, that is all I'm going to discuss on Rapid Spanning Tree. Because in reality, you choose to implement Rapid Spanning Tree, whether it's default or not. You are not really doing much more than that. Okay, the technology pretty much and the protocol pretty much runs on its own. Okay, all right. I can go into really deep lessons on how Rapid Spanning Tree communicates with each other as far as switch by switch. Okay, but it's not necessary. You can do that reading on your own. All right. Now let's take a look at the Rapid Spanning Tree ports. All right, check this out. We got an edge port now. Ports on the edge port, a single host is connected. Port fast is enabled. Okay, if BPTU arrives on this port, it loses the edge port status. This is pretty cool, right? Because you have an edge port, you have your PC plugged into it because it's an edge device, and it gets BPTUs on it. Okay, hey, that could be literally a hacker sitting there sending out BPTUs from an application on his PC. Okay, all right. We got a point-to-point port, which is really awesome. All right, okay, because when you go and look through Spanning Tree, you'll be able to see these indicators, right? Okay, point-to-point, right? It's peer, Spanning Tree. Okay, all right. That means you are Rapid Spanning Tree on this switch. However, the next switch isn't running Rapid Spanning Tree. It's running regular Spanning Tree. So it's going to show you as a STP peer. Okay, awesome. All right. Now, share ports. Okay. These are ones running in half duplex. 9 times out of 10, you're probably hooked up to a hub. Or for some reason, someone coded or it automatically negotiated in half duplex. You know? Okay? Alright? And you can actually use the command Spanning Tree link type. Point to point or shared. Okay? If I was going to hook it up to a hub, man, I gotta give me a hub. You will see that it's hooked up as a shared device. Okay? Okay. Alright. Now, I'm going to cover real quickly. Okay? And I mean real quickly. Alright? When switch 2 and switch 3 get BPTUs from each other, okay? Alright? It's going to go through its stages, okay? It's going to go through its listening, learning, and forwarding, okay? But remember, with Rapid Spanning Tree, each switch are sending BPTUs for each other, okay? All right, and I mean really quickly, that's it, okay? All right? It is your job to go through and understand this, and I'm telling you, besides me going through it, okay, and listening to me talk, you'd be better off going to Cisco documentation, okay? All right? This is some of the things I wish I would have done in my original training, okay? And when I mean training, I mean teaching. Because sometimes explaining something with Cisco documentation is so much better. Okay, you're doing the person an injustice. All right, and we're not doing that. Okay, all right. So this is something that I would do at a CCNP level. Okay, not a CCNA level. Um, okay, and of course your topology changes. Okay, still the same thing. All right. Okay. So just remember that when you get a BBTU with the TC set, which is the topology change flag set, it clears the MAC address learned on all its ports except the port the TCN came in on. Okay. It starts a TC timer, TNC timer, and sends BBTUs with the TC set out all designated en route ports. Now you gotta ask yourself, why would it send out a designated port if there's a blocking on the side? That's the thing. That's why I want you to look at every switch as a separate entity. Okay? That switch doesn't know on all the sides blocking. Okay? Or maybe it does because it actually looks at the whole topology. But it knows it's a designated port. That's all it knows. Okay? And it's not sending out BBTUs because it's not the root bridge. Okay? Right? So, this is how it looks like these devices are communicating with each other. Okay? Alright? And responding to each other and stuff with, so on and so on. And all they're doing is doing their job as a response to a certain flag being set to 1 on a header or in the actual data. Okay? Routers are the same way. Look at every switch and every router as a separate entity, okay? And you'll start going a little deeper and saying, well, this router is supposed to do this. This switch is supposed to do this. Maybe it's not getting the messages it's supposed to be getting to respond to what it's supposed to, okay? And that gets you into another level, all right? Okay? Now, we are done with span tree, okay? All right? This section really was supposed to be a lot deeper, but learning span tree in its own has enough stuff to deal with, okay? Just adding things on doesn't make you smarter, all right? It never has, okay? And at some point, you have to say, you know what? That's enough of the basics. This is something that we're not going to go deep into, but I need you to know that it exists. You know, right? So from that aspect, I did my job because at some point, you'll be like, well, maybe this is a rapid spanning tree issue. Let me dive deeper. I know the basics of it. I know it exists. Okay? All right? And you know what? Let us go a little bit deeper and start doing research, okay? Because that's our job, guys. All right? Lots and lots and lots of reading. All right? The learning never stops, okay? So, be strong, be determined, be Cisco.